We're going to add these two fractions now. I'd love to be able to add them straight away, but I can immediately see I don't have the same denominator. So the parts of my fractions that I'm trying to add are not the same size. So I'm going to have to do something about that. Okay, so first of all I'm just going to estimate. What will my answer be? 5 out of 24 parts in a whole, that is not a lot at all. That's maybe a quarter, if that. 9 out of 60 parts of a whole, well, that's quite small too. So I would say that my estimate, I'm thinking my answer needs to be less than 1. And so if my final answer comes out to be much bigger, I'm going to remember to come back and have a look. Okay, so I know that I can see my 24 and 60 as my denominators are not the same. So the process we use to find a common denominator uses factor trees and Venn diagrams. So off to the side, I'm going to do a factor tree of 24, and I'm looking for factors of 24. 12 and 2, 6 and 4, it doesn't matter. 12 and 2 make 24. 2's a prime. I'll circle it now so I know that's definitely a prime factor. 12 and 6, well, that 2 and 6, that makes 12, another prime factor. 3 by 2 also makes 6, so there's my prime factors of 24. I'll do the same now for 60. Factors of 60 are, let's say, 6 and 10. It doesn't matter which factors you choose, you just keep going until you get to prime factors. 3 and 2, 2 and 5. So if your factor trees look a little different to mine because you started with two different factors, that's okay. You should still get the same factors down here. Okay, into the Venn diagram next. So I draw two overlapping circles. Any factors that both numbers share, they both share a 2, and I'm putting it in the overlap. They both share another 2 into the overlap, and they both share a factor of 3 into the overlap. Those leftover factors, 2 over here, is going to go just on its own, still within the circle of 24, the factors that make 24, and the factors that make 60, we've already got 2, 2 and 3 covered, we just add in 5. Now why do we do all of this? We do this because we can get two pieces of information out. We can get the highest common factor, but we don't need it when we're adding fractions, but it would be 2 by 2 by 3. So that's the highest factor that they have in common, which is 4 by 3 is 12. So 60 and 24 both have a factor of 12, and it's the biggest one we can get the highest one. We don't use that when we're working with fractions and we're looking for that common denominator. We actually want the other piece of information, which is the lowest common multiple, which is going to tell us the lowest common denominator. And that's what we're going to use. So to get that, we multiply all of these numbers together. 2 by 2 by 2 by 3 by 5. I'm going to use a bit of number sense here. I don't want to have to work out 2 by 2 is 8 and then start multiplying by bigger numbers later. I know multiplication has the any order property. I'm going to put the biggest numbers first, and then I can double my way to the answer. So working from left to right, 5 by 3 is 15, 15 doubled is 30, 30 doubled is 60, and 60 doubled is 120. This is the lowest, the smallest multiple that our two numbers 24 and 60 have in common. And you get pretty quick at this. So once I've worked out that my new denominator is 120, I go back up here to my fractions. So I'm going to rewrite these two fractions as some fraction of 120 plus another fraction of 120. So my parts are the same size. Now how do I do that? I think about the denominators first. What would I need to multiply 24 by to get 120? Well, 10 24s is 240, that's twice as much, so I'm going to multiply by 5. Now if I just multiply the bottom denominator by 5, I've changed the size of the parts, but I haven't compensated for the fact that I've got a numerator of 5. So I actually multiply by 5 over 5. These two digits are always the same, because 5/5 is just one whole. And when you multiply by 1, you're not actually changing the number size, you're just writing it in a different way. So 5 by 5 is 25. So 5 24ths is exactly the same size as 25 120ths. Now let's see what we can do over here on the right hand side. 60 by 2 will give me 120, so the digit on the top must be the same. 60 by 2 is 120, and 9 by 2 is 18. So 9 60ths is the same as 18 120ths. And that's going to be helpful for us because now our denominators are the same. We can add up the parts. So on the bottom, you don't have to write this line, will be 120. And in the numerator, you're adding 25 plus 18. And you don't have to write that line if you don't want to. 25 plus 18, well 25 and 10 is 35. 35 and 8 is 43. So I have 43 120ths altogether. I'll just make a note. Can I simplify? So we must at least look for any common factors. Can we divide the numerator and the denominator by any common factors? In this case we can't, so we would say no. Final answer is 43 over 120. And when I check way back here with my estimate, I said we started with two pretty small fractions, well less than 1, and so we were expecting our answer to be less than 1. So out of 120 parts, we only have 43, not even half. And so we can be pretty confident that our answer seems reasonable. So to summarize, we need to find a common denominator, and we do that by doing a factor tree, a Venn diagram, and then multiplying every factor sitting in that Venn diagram to get our lowest common multiple, and that's our lowest common denominator. That tells us what our denominator will be, and then it's a matter of multiplying each individual fraction by a type of 1. It's really just the number 1, but written in different ways. 2 halves, 5/5, but we choose the way we write it so that we get that denominator of 120. Once we have the bases that are the same, whether it's adding or subtracting, we add or subtract, adding in this case, our numerators, and we look to simplify. And often you can simplify, often you can write as a mixed number with a whole number and then a smaller proper fraction. So make sure you check that and make sure you look to see, is your answer reasonable? And if you've got to a reasonable answer, you can be pretty confident that you've done a good job.